Okay, so we're going to re-record this just because the sound was working. So this should be a little bit easier to follow along. So this is kind of the last little bit of the energy unit. We're going to talk about work and power and kind of how they relate to energy. So the first thing is just why do we need energy? So really we need energy so that we can actually do things, right? We can do work. So that's kind of the fancy physics word for actually doing something. Okay, so the definition of energy is just the ability to do work, right? Like think about if you get really tired and you had to go run a mile, would you be able to do that? If you haven't eaten, let's say you haven't eaten in 2 days, would you be able to go and run a mile? Maybe lift some weights? Probably not, right? Because you don't have any energy. You can't do anything. You don't have energy, okay? So let's look at work more specifically. What does that word actually mean? Work is just basically transferring energy through motion. Okay, so what we're saying is that anytime we've actually exerted some kind of force and we've caused an object to move, then we've done energy. We've done work. Okay, so like for example, lifting up these books to the top shelf, you're doing work because you're moving them with a force, right? You're pushing the books, you're lifting them, you're pulling them, you're applying a force, and you're actually causing them to move, okay? And it takes energy to do that, okay? It takes energy to do that work. So we have a formula here, right? You can write down this pyramid if that helps you remember the equation, right? We have force. Our work is just our force times our distance. Okay, so let's look at a quick little practice problem here. Okay, so a game show contestant, these are on your notes also, pushes a bowling ball 20 meters and her force is 73.5. So how much work was done? So we're just going to plug it in, multiply those together. And then when I type in my calculator, 73.5 times 20, I get 1470. And then we're going to use the unit joule. Okay, that's what we measure work in. All right. So you should be able to solve number 2. It's the same exact thing. You have a distance and you have an amount of force. Okay. So we also can talk about what makes it easier to do work. So for example, I've got these 2 guys, they're moving some boxes. Which person is wasting the most energy? Right, well this guy, obviously, right, he's sweating a whole lot. He looks like he can barely take another step, right? He's used a whole lot of energy to move 3 boxes, where this guy over here, he looks happy. He doesn't even look like he's trying, right? So he's kind of got life a lot easier, right? What helps him? What do you think is making his life easier? Why is he not wasting a lot of energy? Well, he's got this little cart, right? So he's able to do the same amount of work that the guy carrying the boxes is. He's moving the boxes the same amount of distance, right? But he's actually not using as much energy because he's got this cart with him. Okay, so what we call that cart is actually just a simple machine. Okay, so we can use simple machines to help make our work easier, right? It doesn't decrease how much work you've done, okay, or doesn't necessarily even increase how much work you've done, but it just makes it easier to do. So over time, you can actually do more, okay, because it uses less energy. One other term we need to know is the term efficiency. Okay, so you've probably heard this term before, right? How can you be more efficient at doing something? So efficiency is just how much work you're doing compared to how much energy is lost. So if you're doing a whole lot of work and not using a lot of energy, you're being very efficient, right? That's like when we're talking about machines, right? We want to have an efficient machine. Think about a car, right? Your car is a very efficient machine. It can drive you all around the town, right? All around the city. But if your car isn't working right, it's not very efficient. Maybe it uses too much gas. Maybe something's wrong with the oil. Okay, if something's wrong and you can't actually get going, or you can't actually do as much as you thought you could, you're actually wasting a lot of energy. It's not very efficient. Okay. One thing to know though is that no machine is going to be 100% efficient. We're always going to lose energy somehow. Okay. Remember, we just talked about how energy can be converted into different types of energy. So some ways that I can use energy is lose energy is sound. Okay. So think about that rolling cart using the boxes. It's not silent, right? You can hear it coming down the hall. And then also we can lose energy due to friction. Okay. That creates heat. That's why a lot of times, like machine parts, a lot of machines are made of metal. A lot of times those machine parts will go bad, right? Because or have to be replaced because they rub against each other for so long. They're creating a lot of friction or a lot of heat. They're losing energy from heat, and it kind of causes them to wear down. Okay, so that's one thing just to keep in mind. That's what we just talked about. All right, the last little term we need to look at is power. Okay, that's where we're actually looking at how much work we've done over time. Okay, so power is kind of related to efficiency. If I have a very efficient machine, I'm going to be able to, it's probably also more powerful. Okay, it can do more work over time. Whereas if you have something that's not very efficient, right, if it's losing a lot of energy, it's not really able to do as much work over that amount of time. So this is just an example of power, right? Ben and Bonnie, they're lifting the same dumbbell, the same distance. So they're doing the same amount of work. They're applying the same amount of force. They're moving the same distance, but Ben's more powerful because he can do more reps or he can move it quicker, in that time frame than Bonnie can. Okay. So these are some simple machines here that you've probably already learned about a lot of these, like a pulley, right? We know what a pulley is. It makes it easier to lift things. A wheel and axle, that's anything that has wheels. Cars, right? Wagons, carts. Okay, that moving cart that he was using for the boxes. Some things that maybe aren't as familiar is maybe a wedge. So a wedge can be used for two different things. It can actually hold things together. Okay, like for example, a staple. Okay, holds 2 pages together or 3 pages together, more pages. Or it can actually split apart. That would be like in the axe. Okay, it can kind of wedge in there, it can split apart, or like a door stop. A door stop is a wedge because you can wedge it up under the door and it keeps the door open or apart. An incline plane, usually we use that to help us get either up or down quicker. And then a screw has a very similar function to the wedge. It's going to hold together. Okay, but the difference between a screw and a wedge is that a screw always has to twist in that circular motion. Okay. We have compound machines. That's just where we can combine some simple machines together, like scissors is a wedge and a lever because it goes up and down. The scissors cuts through or separates the paper, right? A wheelbarrow has a wheel and axle, and it also has a lever because it can go, you push it up or down with the lever. Okay, the last part of this that is going to be the part you're turning in today is the Rube Goldberg machine. So what Rube Goldberg is a cartoonist, and he actually drew these very silly. Hang on. Go talk to Dad, please. So Rube Goldberg is an American cartoonist from like the early 1900s. He would draw all these really silly cartoons. Here's some examples. And basically he would make something that was a very simple task, like wiping your face with a napkin or opening an umbrella, into this very complex process using all these different simple machines. Okay, it was a joke. No one would ever really build this. It was just a joke. So like, for example, in this one, he's trying to wipe his mouth with a napkin. So as he lifts a spoon here, right, it pulls on this one. It makes this little cracker launch. The bird eats it. When he does, it spins this screw here around, knocks the water pail, which is on a pulley, pulls the rocket. So you can see there's lots of steps, lots of machines, right? You got a lever, you got a screw, you got a pulley here. And so he combined all these to make some silly contraption. Okay. Like I said, there's just some more little examples of things in his cartoons. So what your assignment is for the day is there's a YouTube video of a band, OK Go, that made a giant Rube Goldberg machine for their video. Okay, so one thing to know about Rube Goldberg machines is they always have a purpose, right? So they always have some type of purpose, like wipe your mouth with a napkin, open an umbrella. So in the video, you'll see the purpose is to actually shoot a paintball gun. Okay, so they go through all these different steps. So your job is you're filling out the chart and you're just trying to identify a couple different places where their simple machines are in that big giant Rube Goldberg design. Okay, so just make sure you read the instructions on that, and that'll kind of help you fill that out.